In this video, we will be looking at piecewise defined functions. A piecewise defined function is defined by different rules over different intervals of the domain. An example, here we have the function f of x, and for the domain elements less than 1, my y is defined to be y equals 2x plus 4. So I use the rule 2x plus 4 whenever x is less than 1. When x is greater than or equal to 1, I use the rule y equals 4 minus x. Now we can evaluate functions with piecewise defined functions. If I were asked to find f of negative 5, that means x is equal to negative 5, and I want to find the y value that's associated with that. If x is negative 5, that means that I'm going to have to use the first rule, or the top rule, and so I know then that 2 times negative 5 plus 4 is my y value. This is negative 10 plus 4, so negative 6. F of negative 5 equals negative 6. If I were asked to find f of negative 1, again, negative 1 is to the left of positive 1, so I'm going to use the top rule. And I would have 2 times negative 1 plus 4. This is negative 2 plus 4, so 2. F of negative 1 equals 2. This time x is 0. 0 is still to the left of 1 on the number line. 0 is still less than 1. So I'm still going to use the top rule. And I have 2 times 0 plus 4, which is 4. F of 0 equals 4. And for this one, I'm told that x is equal to 1. This means that I'm going to have to use the bottom rule because I use this rule when x is greater than or equal to 1. So use the bottom rule, and that rule is 4 subtract x. So 4 subtract 1, because my x is 1, and this value is 3. To evaluate f of 3, since 3 is greater than 1, I'll be using the bottom rule. And that says that 4 subtract x, and my x is 3. We can also graph piecewise defined functions. What we have to keep in mind is this barrier that we change rules on the left side of 1 and on the right side of 1. So I'm going to set up a t-chart. and I'm going to pick a few numbers to the left of 1. So when x is -2, -1, 0, 1, that's my boundary when x is 1. So I'm going to use, for these numbers, I'll have the top rule. And then for numbers greater than or equal to 1, again, I'm going to include that boundary. Notice that this is going to not be included in the graph, but I need it to get the actual boundary point. So 1 I'm going to include on both of these values, and then I want to go bigger than 1, so 1, 2, 3, 4. And this rule then, for numbers greater than 1, I'll use this lower rule, which is 4 minus x. Alright, so on this one I have 2 times -2 plus 4. This is -4 plus 4, which is 0. On this one I have 2 times -1 plus 4. So -2 plus 4, which is 2. For x equals 0, I have 2 times 0 plus 4, which is 4. And for x equal 1, I have 2 times 1 plus 4 equals 6. For these numbers, I'm going to use the bottom rule, which is 4 minus x. So I have 4 subtract 1, which is 3. 4 subtract 2, which is 2. 4 subtract 3, which is 1. And 4 subtract 4, which is 0. Now let's plot these points, keeping in mind that my barrier is x equal 1. So I'm going to put a little dotted line here to remind myself that this is where the barrier is. When x is -2, y is 0. When x is -1, y is 2. When x is 0, y is 4. And when x is 1, y is 6. But on that top rule, it's for x's that are less than 1. So I have to put an open circle at this point. Open circle here. So when x is 1, y is 6. And I have an open circle there, meaning that I don't include that point in my graph. So to the left of x equal 1, you can see that I have a linear function. Now you can ask yourself if this makes sense. On this y equal mx plus b, my y-intercept is 4, which, yeah, and my slope is 2, which is up 2, right 1. So that one fits that y equal mx plus b on that one. All right, let's go ahead and graph to the right of x equal 1. When x is 1, y is 3. Now on this one, for the bottom rule, I am allowed to use that point. When x is 1, y is 3. So I'll have a solid dot at that point. Then when x is 2, y is 2. When x is 3, y is 1. And when x is 4, y is 0. So on this side of x equal 1, on this side of that barrier, I have a linear function with a negative slope. Keeps on going forever that way. And you can kind of check yourself again on this one. The rule here, the slope, the m value is -1, which holds true on our graph. And the y-intercept, now I can't actually come up and cross the y-axis because I'm stopped at this barrier. I can't use this bottom rule for anything less than x equal 1. But I can imagine that if this line were to continue up, that yes, it would cross at 4, which is my y-intercept.